super excited to be here, to be representing Virginia Tech and to share some of the things that we've been doing with containers and whatnot. So I'm going to slide over to my branded talk. So I want to start off with a little bit of a story. Okay, so about 6 months ago, I was sitting on an interview panel for a candidate that we're trying to fill a position on our team. And we were explaining to a candidate about our application stack and how we're using containers in dev and pre-prod and prod and pretty much everywhere we're using containers. And later when we gave him a chance to ask questions, the only question he asked us was, so you mentioned you're using Docker. Does that mean you have a bunch of microservices? And to me, I was just like, no, we're not. And it confirmed to me something that I'd heard many times that Docker's been talking about itself, about microservices, and that containers aren't just for microservices. In fact, at DockerCon EU in Copenhagen last year, Docker's new CEO, Steve Singh, said legacy apps deserve love too. Okay? That all these applications that we've been running, that we've been maintaining in our systems, that, well, we need to give them attention too. And they deserve and need the containerization benefits that come along with it. Okay? So now, just purely by chance, okay, no pre-plan beforehand or anything, I was at DockerCon EU, okay, and I had 2 inflatable Dino suits, okay, and so I was looking for reasons to use them. I was working with Abby Fuller, and we were conspiring, Abby Fuller at AWS, and we were trying to figure out ways to use these Dino suits. You know, maybe we could crash a talk or 2 or something like that with them, or do something crazy. And so when we saw this quote, we said, hey, that's something we can use. Okay, so what if we made these little protest signs, and we crossed out legacy apps, and we write Dino apps deserve love too, and modernize your Dino apps, and throw a hashtag Dino selfie on it just for fun, and let's run the venue hall. Okay, and that's exactly what we did. So here's a lot of selfies that we got from it, and it was a blast. And of course, I couldn't fit them all on here. We see a couple of people from Docker. In fact, Brett Fisher, who's going to be speaking next, he's down in the bottom left. Shout out to Brett. So we just had fun, okay? Because these types of apps, well, they need the attention. They deserve love too, okay? So how am I defining Dino apps here, okay? So for the purposes for this talk and how we're treating them at Virginia Tech anyways, I'm going to define a Dino app as any application that's not under current active development. Okay? So for example, at Virginia Tech, we have hundreds, probably even thousands of these apps that were written by students, that were written by professors, that are serving some business value, some use, but the people that wrote the software, there's a good chance they're not here anymore. They're being maintained, they're on a machine, and everybody's thou shalt not touch that machine, and it becomes a situation like this in which you need a very careful architect and somebody that's trained to work around the application because we don't want to break the app. Okay? And we have a lot of these. In fact, I was chatting with a director for a department, and he was saying that he's been tasked to figure out what applications they're running in their department, and he's like, I have no idea. Okay, I've talked to a couple people, and I found out, hey, there's a desktop machine in somebody's closet that's running this application, and they're just constantly finding these things. Okay, and yes, I recognize that's been a problem with how we manage our applications, but that's pretty consistent in the higher ed space. When we just kind of give everybody network access, and I can connect a box to that, and I can throw my app on it. Okay, so we've got a lot of these Dino apps, and I would bet in your organizations and your enterprises and your companies, whatever, you have a lot of these kind of apps as well. So let's talk about what value we can get from containerizing these applications, but then what can we do with them once they are containerized? Okay, so that's how I'm going to split this talk up. Okay, first off the how, okay, and then I'm going to talk about the why. What huge benefits do we get from it afterwards? Okay, just quick side note, I like using memes in my talks. Anytime that my boss asks me for feedback about his slide deck, it's always there needs to be more memes and there needs to be more GIFs in it. Okay, yes, I say GIFs, anyways. So how and why? Okay, so the migration journey. Okay, so we're basically describing a 4-step process here to containerize our application. Okay, first off, we want to be able to build the app. Now, this step may or may not apply to all applications. We'll talk about that here in a second. We want to be able to put it into a pipeline so that we can run these steps every time that I push code or I push updates to the repository. I want to be able to build the entire runtime for my application. Okay, And then I want to be able to test the app. And then we'll start to see some of the real magic that comes along with containers. Okay? And we're going to do this all without changing a single line of code in the app itself. Again, the app itself was written by a developer that's not here anymore. So what can we do around the application to get these benefits? Okay? So first, some prereqs. Okay? In order to do this, your application needs to have some way to configure it. Okay? So it needs whether it takes config files or environment variables or whatever it is, there needs to be some way to configure your application for different environments. All right? Obviously, you probably shouldn't, well, you shouldn't. You should never bake your secrets into your container images. Okay? There are ways to make your secrets available to container images. I'm not going to really talk too much about that, but that's worth a whole talk of itself there. Okay? And one thing I want to mention too, these 4 steps that I highlighted, which we'll see again in a couple, we'll see over and over again, each of these steps should be considered big milestones, okay? In which if you only get 1 out of the 4 steps, that's a success. That's now something that you weren't able to do before, but now you can, okay? And so hopefully, yeah, you can get through all 4 steps, but if you don't get through all 4, you should still consider each step a success, okay? So for the purposes of this talk, I've actually made a simple Dino app, a legacy application. It's actually written in Spring 2.5, which is ancient, and it hurts to write. Any Spring developers in here? Okay, there's like 2 hands. Wow, okay, not too many. But so anyways, it's an old application using basically frameworks that were current about 7-10 years ago. Okay, there's much better ones now. Again, I wanted a legacy app here. And then my little simple web app, and we'll see a little bit more of the architecture about it in a little bit. It's cheap chomp, okay, so kind of go along with the Dino theme. It's the cheap places to chomp or eat on campus. Okay, yeah, dad joke intended, but that's all right. So with this application, administrators can log in and say, all right, I can manage my data centers, I can put, or my dining centers, and manage the daily specials for them. Okay, pretty simple. Again, we'll dive more into the architecture in a few minutes. Okay? So step 1, I want to be able to build my app. Okay? So the goal for this one is I want to be able to reliably and reproducibly be able to build my application. Okay? This applies pretty much, for the most part, only if you have an application that requires compiling. Okay? So at Virginia Tech, most of our enterprise level applications are all in Java. So obviously we need to compile the Java code. Okay? So the questions that we need to ask are, what tools are we using? What version of the JDK are we using? Are we using Maven? Are we using Gradle or Ant or whatever? What tools are we using to actually do this compiling? Okay? Do we know what versions worked last when we deployed the application? Are dependencies pinned to specific versions? Now, this is one that I get bitten with quite a bit if I'm doing a Node app. Okay, maybe I didn't lock the dependencies in my Node app, and now it downloads an update and everything breaks because for some reason JavaScript developers have really no idea what symver actually means. So make sure that your dependencies are pinned. Okay, and some tips. Okay, and we'll see this here in a second too. For this, I'm going to use Docker Compose to just make it easy to launch. Okay, to do my build and to get the output, get the artifact of my build back onto my host machine. Sure, I could use a Docker image build and do everything within an image, but then how do I extract the artifact out of that image and do something with it? So we'll see that here in a second. Okay. Another thing, so for example, again, we're a Java shop. We use Maven quite a bit. And with Maven, you have repositories on the local disk, so I want to make those available to my image so I don't have to re-download those dependencies every time. And we'll see that here in a second as well. So let's build this app, okay? So over here, all right, I've got my Docker Compose build. Is that big enough for everybody, or do I need to make it bigger? Good? Okay. All right, so I've got a Docker Compose file. It's pretty simple here. And for this example, I'm using the image right off of Docker Hub. So I'm just using the official Maven image. I'm using Maven 3.5. That was a version that was known to work for my application. I'm using JDK 7 because, again, we know that it worked with 7. We don't know about 8, 9, or even 10 yet. I'm just going to use JDK 7. Okay. Now, what I'm doing is I'm mounting in my source code into that container, so when it starts up, it has the application, and then my command, I'm just running a Maven install. Okay. Now, again, sure, I can do this on my host. I can do this directly on my machine. I can install Maven, but now by using a container, now I don't have to install anything on my machine. Okay? I don't have to figure out how do I swap between versions of Maven, how do I get the right JDK, all that stuff. It's now all happening in a container, okay? I also mount my Maven repository just so that I don't have to re-download those artifacts every time. So I'm going to do my Docker compose, and I'm just going to do an up. So those of you that know anything about Java program, I mean, you'll know that there's usually a target directory in here that has the output. Looks like I'm squeezing the HDMI cable. Okay. And so what I'll do is I'll go ahead and run this. Oops. Let's see. Okay. All right, so we'll run the build here. We'll see that it's kicking off my Maven build inside a container. We see my target directory just get built here. And again, since this is a simple application, it doesn't take too much. It's not going to take too long. My build is successful. I open up the target directory, and there's my war file, my output of my Java build there. Now again, I can do all this on my machine, but now I'm doing it in a container. It's reproducible, and I can do this over and over. I can share this with somebody else, and they can use this Docker file and spin everything up without having to install anything on their machine. Okay. All right. So let's move on. So let's put it in a pipeline. Okay. So the advantages of putting in a pipeline are I get automated builds whenever I push updates to my application. So if I took this Docker compose file now and I build a pipeline with it, every time I push the code, theoretically it's creating my war file in this container. Okay. And so I can extract that war file. Maybe I'm not ready yet to actually build the full Docker images, but now I can just download the war file from your artifact repo, whatever that may be, and now I can deploy it using whatever manual processes I was using before. Okay. So one of the things I'll mention too, here's a couple tips here. Use pipeline as a code whenever possible. Try not to configure everything in the pipeline system. So what I mean, for example, older versions of Jenkins, I would have to log into Jenkins and I would configure the build and everything inside of Jenkins. With newer versions of Jenkins, you can use a Jenkins file. We at Virginia Tech use GitLab. I have a GitLab ci.yaml file that's in my repository. Basically, you want to have some sort of text file, some declarative description that defines here's what your build looks like for your application, and it should be versioned with your code. Okay? Again, use whatever tools are available to you. If you already have GitLab, great, use it. We love it. It's fantastic. If you're already a Jenkins shop, use it. It doesn't matter. Just use whatever you have and make it better. Okay. Now, so just because of time, I'm not actually going to build the pipeline, show it, all that kind of stuff, because again, it's getting really specific to how we do things. But I'll just show you, so in GitLab, once I've got a pipeline built, I push it up, it triggers my build, and so in this case, I name the stage compile, and so now it's going to do the compiling step that I just showed you guys, and so that build that I just did is now happening every time I push updates to my repository. It's going to rebuild my war file, and now I can make that it's, again, reproducible, and it's happening every time. Okay, so if you don't already have that, do that. Okay, so step 3, now that we actually are able to build the app and compile the app, let's actually make the rest of the runtime. Okay, so the goals here are to be able to produce a Docker image that contains everything that my application needs to run. So we're going to basically build on the first step and now give it the rest of the runtime. All right, so some things to think about. What was the last known state that worked for this application? Okay. So again, this is a Dino app. It worked in an ancient version of Tomcat. Okay, it's not that ancient. We'll be using Tomcat 7. So what versions of the server do I need to use? What dependencies does it have? You need to think about all these different things. And honestly, the easiest way to do this is say, hey, sysadmin, pretend that you're going to set up a new machine for me. What are the steps that you need to do to set up a machine? Okay. What things do you need to install? What dependencies do you add to that server? What do you need to set up this app? Okay, and let's take those things and figure out how to actually make a Docker file out of it. Okay, so then once I can build the runtime, okay, now I have an image I can actually run my application. Okay, so building the runtime. Now if I jump to my Docker file here, now I'm doing some. Okay, I've got what's called a multi-stage build. How many people have heard of multi-stage builds before? Okay, so there's quite a few hands. Awesome. I'm a huge fan of them. Okay, they dramatically reduce your final image size, and it just gives you a much better image, much more secure image. So totally do it. So what we'll see here is the first stage. All right, I'm sorry, that's flickering a little bit. The first stage here, I have a from Maven 3.5 JDK7, which you might recognize was the same image that I used in the first Docker Compose file. So now I'm basically taking that image, or that step, and now I'm putting it into a Docker file. And that's really my first stage. Okay? So I'm copying in all my source code, I run my Maven install, and then what I'm actually doing is I'm actually exploding the war file automatically here. So then we'll see it in a second. When I copy in the artifacts, it's already the exploded version. I don't have to explode it later. Okay. This one was making another stage just because I wanted another stage. Okay. I'm creating another stage. I'm using Alpine, and basically what I'm doing is I'm just curling all the other dependencies that my Tomcat server may need. And I'm basically just putting it into another directory, this jars directory. And again, that's just all the other dependencies that my application are going to need. Okay, so why do these in different stages? So then in my final stage, I say, all right, I already have this base image that's Tomcat with CAS. I'll talk about what CAS is here in a second. Tomcat 7085 JRE7. Okay, and now I'm going to copy the artifacts from the other steps and now bring them into this new image. So all the jars that I downloaded as dependencies in this stage are now being copied into the final image in this step here. So if I decide that, all right, I need 6 or 7 jar files, well then I just add more curl statements here and pull those in. The reason I do this as a multi-stage build, because technically the add command in a Docker file can fetch remote resources. The reason I do it this way is it's faster. Build caches as well. For the add, it still has to fetch the file and find out did it change in order to find out can I still use the cache layer or not. In this case, I don't have to fetch the file to check the file differences. So it's just a faster build. Okay. I do one little piece of cleanup in my Tomcat app, and then I copy it in the exploded war file from the other app. Okay. So now, let's pull this up a little bit. Docker build. I'm going to build cheap jump, Tomcat 7, Jerry 7, and this should go pretty quick. Okay. That went really quickly because I built it this morning, and so it's all cached. Okay, I didn't want you to have to sit here waiting for, just twiddling your thumb, waiting for everything to run. So you're welcome. Okay, so now at this point, I have an image that has my war file that we built with step 1, and now I have a Tomcat server that has the war file already exploded and ready to go. So theoretically, I should be able to spin up this application. Okay, so let's talk a little bit more about the application. Okay. Before I do that, okay, step 4 here is testing the app. Okay, what we want to do here is we want to be able to write tests that actually test my application fully end to end. All right, and because I have a container, I can do things that I couldn't do beforehand. All right, so when I write end to end tests here, okay, since this is a web app, I'm going to use Selenium or a framework on top of Selenium. For the examples here, I'm using WebDriver.io. It's a node-based framework. And so I'm going to write tests that will actually launch browsers and execute and basically test the application end to end. All right. Now, so for your team, you obviously want to use the right tools, frameworks, whatever that works for your team. If you're a Node shop, use the Node tools. If you're a Java shop, use the Java tools. But what's cool about this is I'm going to write test code that will end up running in another container, and so I don't have to be tied to the same language and frameworks as the app itself. Okay. So again, if you're a Node shop, write your tests in Node. Great. Even if it's a Java app, which is exactly this setup here, it doesn't matter. Okay, you can choose your language, your framework. Okay, what external services does your app need to depend on? Do you have images for those as well? Okay, because if you do, you can do some really, really cool stuff. For example, mocking data. So at Virginia Tech, a lot of our applications, and this is pretty consistent across higher ed, and probably many enterprises have something that looks similar to this. Okay, so we have a web application. It has a dependency on what we call our enterprise directory. It's basically the LDAP that has, here's all the people, here's all the group memberships. It's all the data about people and groups for campus. Okay? And so we use that for authorization. Okay, are you actually authorized to manage this dining center because your person record is in that group? Okay? This app uses a database for its own local store. We also have a service called the Central Authentication Service called CAS. It's basically just a single sign-on. Okay? So if I had containers for each of these different dependencies for my enterprise directory, for my MySQL database, which MySQL I can just use the public image, and if I had a mock CAS server, what could I do with that? Okay, So pre-Docker, okay, in order to test full end-to-end, we were limited to whatever the team that ran the directory gave us, okay? So they're like, yeah, we have a pre-prod instance, but really that's their pre-prod instance, not what I should use for my pre-prod testing. Because I don't have the ability to go into that directory and say, hey, I want to make these fake people, okay? And so there's no way to really manipulate the data or make mock data, okay? So we can only use whatever they give us, which in this case, the pre-prod server is just a production snapshot that got rolled back. Great. So that means it's real data. We have to protect that. I don't want to just put my credentials in the application to do end-to-end testing, okay? So how do we authenticate it if I can't put my credentials in there? How do we do it fully automated in a build pipeline? How do we do this? And so the answers up to this point, well, the first bullet, well, we just don't. Okay? And that's what most of the teams on campus have decided, well, this is too hard, so screw it, okay? So the second one is, well, we hire a bunch of student interns and tell them to do it, okay? Now this works, I put in quotes, but anybody that's ever done manual testing, I saw several smirks, know that that's hard, okay? And it's monotonous, and it's boring. And there's frequently, okay, I know that this piece of, the code that changed was for this piece of the application that's way over here, so I'm just gonna skip a couple of tests over here because, that didn't change, right? But that's exactly where the thing broke, okay? So, you know, we've had this happen many times, okay? And if we're on faster release cycles, well, how do we keep them motivated to keep testing, okay? And so another thing we can do is we can add abstraction layers to say, well, instead of actually pulling people from the directory, we'll just use a local database people representation. That's what my team did for a while, but it's still, now we have to maintain this code base for different implementations of people, and anyways. But the big gain that we got from that of using this abstraction is now we have dummy data, kind of a local database. But what if we don't even have to do that? So testing with Docker now. Okay, so if I had containers for each of these different pieces, if I had the enterprise directory in a container that I spin up and it gives me my LDAP schema, it's just empty, okay? And if I have my database, that's empty, maybe I populate it with my application schema or the app does it at startup, whatever. And if I have my CAS server in a container, for those of you that know anything about CAS, it's just a protocol, so I can really implement it any way I want to. If I have this, then I could theoretically throw a reverse proxy in front of that and say, well, anything that goes to cas.internal will go to, as you would expect, the CAS app. Anything that goes to app.internal will go to my application, okay? So, all right, now we're starting to build something here, but what if we go beyond this a little bit more, okay? What if I also spin up another pair of containers in which I have one container that's my Selenium driver with Chrome, and so Selenium, the organization, actually provides these containers. And in the Selenium driver container, there's actually a Chrome browser installed, and it's running the Selenium driver API, so that theoretically, if I talk to that API, it's gonna launch the Chrome browser, it's gonna run tests, it's gonna do stuff, okay? So if I use that container and then I write my own test code and I run that in another container, now I have a lot of containers, okay? But this test code, okay, can talk to the Selenium API, which then launches the Chrome browser and basically interacts with my application through the reverse proxy, okay? This sounds pretty cool, doesn't it, okay? Now what's neat about this is I can throw all this in a single Docker Compose file, okay? And if I had this all in a Docker Compose file, then what can I do with it? Well, so Docker Compose has a fairly little known flag on it that I think is just awesome, okay? And it's exit code from, okay? What this flag does is it watches a single service, a single container in the Docker Compose stack, and it watches that service. Once that container stops, it tears down the rest of the stack, okay? And whatever the exit code from that container was, it basically bubbles that up, and that becomes the exit code for my Docker Compose command, okay? So for example, if I spin up this entire stack and I set exit code from this container here, once the test code is done and that container stops, if it has a 0 exit code, meaning that everything passed, all right, once it exits, it tears down all the other containers, and then my Docker Compose becomes that exit code is 0. So, taking that one step further, if I take this command and now put it in a build pipeline, if my tests pass, my build passes. If my tests fail, my build fails, okay? And again, it spins it all up when it needs it and tears it all down once it's done. Awesome, okay? So enough talk, let's actually see it happen, right? Okay? All right, so I have a Docker Compose test file, and I'm not going to go too much into this because, again, this gets really application specific, but I've got my reverse proxy, I've got the CAD server, I've got the app itself, I've got my SQL database, I've got the LDAP where I'm mounting in my LDIF files to populate my LDAP directory. I start the Selenium container, and then I've got my BDD, behavior-driven design. That's my actual test code. Okay, so enough talk. Let's show this off. So you'll see that it's building my containers, it's starting them up, and now you'll see a lot of output. So if you look all the way on the left, those of you that aren't too familiar with Docker Compose, you'll see the service that log output is coming from. So these are from the CAD server. We'll start to see a lot of noise from, there's the BDD test app actually starting the app, the Selenium container. We'll see a lot of stuff happening. Okay, and when you see that it ran, in this case, it just ran 4 tests. All the tests passed, check marks. I got an exit code of 0 there, and once this finishes, okay, my exit code from the Docker Compose was also 0 as well. Okay, pretty cool. Okay, anybody impressed so far? Okay, there's a couple hands. Thank you. All right. So, okay, now what I'll show in a minute too is that there's something else that's really cool about the Selenium container. So just hold on to a second. There's something else that's really awesome about this container. Okay, so again with a single Docker Compose command, I spun everything up. I spun up my application. I did full end-to-end test using a real LDAP, a real enterprise directory, using a real CAD server. I'm not mocking anything. I'm just mocking the data that are in those things, but it's talking to the real services. Okay. And now this allows me to do things that were traditionally impossible to do just because we have containers for all these different things. Okay. So recapping our journey up to this point, we've been able to build the app, we've been able to put in a pipeline, we've built the runtime itself, and now we've been able to test the app. And again, we haven't changed a single line of code in the app itself. Okay. Now this sounds pretty cool. Okay. But now, yeah, why does that all matter? Okay. Now obviously it should matter to you that now we have test code where we didn't have before. Okay. But there's something even bigger that comes out of this. Because what this becomes is, I know, a cheesy photo, but this becomes a foundation. Okay? A foundation to actually do some really, really cool stuff. Okay? So for example, this Dino app that I've modernized here, okay, I've taken it, I've containerized it, and Virginia Tech, we're Docker EE customers, so we've got access to the Docker Trusted Registry. So I can take my image, I can push it to the Docker Trusted Registry, and then it can do a security scan on it. And so when I pushed this application on it, the security scan said I had 26 critical vulnerabilities. All right, that's probably not preferred. Okay, but what's cool about this too is now that it's containerized, I know I have 26 critical vulnerabilities. Where before, when it was just running on some box in a closet, I may have had no idea that that was the case. Okay, so now I'm starting to get a little bit of visibility into my applications. Okay, so again, this isn't preferred. But so what can we do with it now that it's a container? Okay, so what I can do is I can start to do experiments with my container because again, I have this testing platform. Okay, I could say, well, hey, let me try rebasing my application. Let me change my Docker file. So instead of using Tomcat 7, let me try using Tomcat 8 and see if it fixes any of my vulnerabilities. Okay, so all I have to do again is just change a from in my Docker file, and it's going to rebase. It's going to take my war file, and now I'm just putting it into a new base image. Okay, so the goal here is to be able to migrate and change things up. Okay, maybe I'm going to migrate from Tomcat 7 to Tomcat 8. Maybe I'm even going to say I'm going to try to migrate from JRE 7 to JRE 8 or 9 or 10. Okay, I can do these kind of experiments now where before it was basically impossible to do. And all I had to do is change a from in a Docker file. Okay, assuming that those other images are already built. Okay, everything can be changed. Okay. And again, as would kind of make sense, just change one thing at a time. Okay, so if something breaks, you know, okay, what broke, and what might you need to look at. Okay, and I would highly encourage you to do as you make these changes, make minimal, if any, changes to your end-to-end test. Okay, so I should be able to make these changes to my application and not have to test my Selenium code. Okay, if you have to change your Selenium code, it could become compromised, and you're like now you're writing tests to make tests pass at that point, not necessarily testing your functionality of your application. So just be careful of that. Okay. So let's try this out. Okay, so just for kicks, I made a branch just to make it faster. All right, and if we look at my Docker file now, all I did was change the app to now Tomcat with CAS. So instead of using Tomcat 7, I'm now using Tomcat 8. Okay, so I can do Docker build, cheap jump, Tomcat 8, Jerry 7. Okay, and again, I built this morning, so it goes super fast. But now I have an image that's now based on Tomcat 8. Okay, so let me try running my tests again. Okay, and again, while this is running here, I'll jump back to this slide. Okay, so this application, just think of it as a box. If I move it from Tomcat 7 to Tomcat 8, all right, I'm changing this app, but everything else around it is staying the same. So my test will be able to tell me if that was a safe rebase or not. Okay. Let me jump back here. Okay, so we see that running. Now, I'm going to show off one cool thing here in a second. Actually, maybe I'll do it for the last demo, just to make it more fun. Okay. All right, and so just to prove that this wasn't smoke and mirrors, because every time I do a demo on campus, there's the old gray beards that are like, yeah, you're just kind of, you're just making this up. You're just scripting this. I'm like, can you really script console output like that? I mean, that would be pretty impressive if you could. So I'll actually find Tomcat 8. So this first one that's the CAS server. That was actually Tomcat 8. But now we actually see the app itself is indeed running in Tomcat 8. Okay, so it really was testing what I proclaimed it to be showing. Okay, now, okay, so since my test passed, if I scroll back down, since my test passed, I know that my application can now safely run on a Tomcat 8 application server, where before I didn't. Again, that was bones in the dirt that everybody was scared to work with. And by just changing a from and a Docker file, I've rebased my application onto a new stack, and now I can do something that I couldn't do before. Okay? All right, so let's continue on. So I push it up, and okay, my major dropped, but I still have 26 critical vulnerabilities. Okay, crap. All right, so it didn't really help out in that regard. In fact, actually, when I did this a couple weeks ago, for some reason, going from Tomcat 7 to Tomcat 8, that rebase actually added another critical vulnerability. I'm like, really? That's not how this is supposed to work. Okay, so at least I haven't made things worse. Okay, I've made a little bit of improvement. But again, what I can do is use this as a platform to experiment and try. Okay, so this particular Tomcat 8 JRE7 was built using a Debian base. Okay, so what if I now did another experiment and said, well, let me try using a base that's maybe on Alpine. Okay, do I reduce my vulnerabilities, and is it a safe rebase to make? Again, change my from in a Docker file, run my test, know if it works, push it up, scan it, and now I'm down to 5 critical vulnerabilities. Okay, so it's dramatically reduced the number of vulnerabilities, again, just by experimenting and trying because I have a foundation. Okay. Now, if I look at these critical vulnerabilities, one of the things I'll notice is that my app itself is providing one of those vulnerabilities. Okay, so what the screenshot is showing here, this is the copy, and where it's copying all the exploded war file into the final image. Okay, so the crazy long hash, that's just the hash of the file copy there. And so it's saying my tag libs, that jar file, that dependency has a vulnerability. Now, of course, I need to look at the vulnerability and find out, okay, is it something people can actually exploit? Can they do anything with? Okay, but this dependency is pulled in by the Spring framework, and I don't want to touch the app itself right now. I don't want to try to modernize the framework. I'm trying to see how much I can do with just the container. Okay, so my options to solve this are, well, hey, rewrite this app into Spring 3, 4, 5, whatever, okay? Or maybe I can raise the bar to make it a little bit harder, even if somebody was able to compromise this application, okay? So again, this is another experiment I can try here, okay? So one of the things that we've been trying at Virginia Tech is to use the read-only mode in containers as much as possible. How many people have heard of the read-only mode? Okay, there's like 4 hands. Okay, awesome. So I get to teach you, hooray. So when a container starts up, remember that the image file system, there's a union file system that gets created, and the image itself is read-only, okay? And the container itself gets its own writable layer, okay? With read-only, that writable layer, the root file system is read-only. So no changes can be made to the file system of that container, okay? Which is pretty powerful. But at the same time, it's like, wait, I have some applications that are writing log files. If the root file system is read-only, how does that work, okay? And so that's where the second bullet point comes in. So any locations that still need to write files, use tempfs. Okay, and so files, it's an in-memory file system there, and once the container stops, boom, that obviously the memory goes away, and all those files, those changes are gone. Okay, now so caveats with this. Okay, using read-only it's not going to solve all of your problems. Okay, again, this is just another experiment. I'm raising the bar. I'm trying new things out. Again, it just makes the file system of that container read-only. But if your container is talking to other containers, for example, the database, well, that database probably isn't read-only, and you probably don't want a read-only database. It kind of, at least if you're actually wanting to write data, it kind of goes against what you want to do there. So your application, the vulnerabilities, you need to look at them and find out, okay, is this vulnerability opening me up to SQL injections or data dumps or exposure, that kind of stuff. Okay, so if those vulnerabilities are at play, read-only is not going to help you out for the application container. Okay? And again, this isn't meant to catch all, but it's raising the bar. So even if somebody could do remote code execution, they can't install packages, they can't do anything because the file system's read-only. So it's at least raising the bar. And again, this was a legacy app that was running on some old machine, and now we're running it in a read-only root file system. You know, it just is awesome. Okay. And again, if you want to continue raising the bar, I would advise you look at AppArmor and SecComp and all these other things, or just update your app to remove the vulnerabilities too. Okay. But again, you take all these things and put it together, and now you have a good framework to work with. Okay. So I'm going to do one last demo here. I keep getting Git and Docker commands mixed up all the time. I do it all the time. All right, so I'll check out my read-only branch. Okay, and so I have a read-only compose file here. Where did my app go? Okay, in which I add the read-only flag to say, okay, this application is going to run read-only, and these are the directories that I want to allow files to be written in. It's going to create tempfs mounts for those. Okay, and what I'm going to do a little bit differently this time, okay, is when I run this code, one of the things I didn't mention is this Selenium container that I'm using is the Selenium Chrome, or yes, let me make sure I get it right. The standalone Chrome debug container, okay, and it has a VNC server in it, okay, running, which means I can RDP in it and I can actually watch it do the test, okay. So let's try it out. So I'm going to jump over here. Oh, hey, look, it's my cute family. Okay. So yes, I have 3 girls with a 4th girl on the way. So, and it's awesome. Okay, so at this point, I have a screen sharing. I'm in my container, and I'm seeing everything that's happening. Right now, there's nothing happening yet because it hasn't launched the browser. But we'll actually see it start running these tests here in just a second. Okay, so there's the Chrome browser starting up. And we see it just flipping through pages. It'll do the login through my mock CAS server. It runs my containers, or my tests. Once the tests are done, the container goes away, so it's going to give me, boom, it's trying to say, hey, reconnect because I lost my connection, that container died. Okay, so that's actually super helpful. A lot of times I leave this up when I'm trying to write my Selenium stuff so I can see what's actually going on. You can actually do cool stuff like set up your Selenium server to, if a test fails, it can take a screenshot and dump it onto your machine so you can actually see what failed or what was the state of the screen at that point in time. There's pretty cool stuff you can do. Okay, so let's jump back here. Okay, so my tests, again, running in read-only mode, my tests still pass now, so I've got the right combination of tempfs. And actually, again, when I was experimenting with this, I didn't know what tempfs mount points I needed. So I would say, all right, I see an error that says, hey, I'm trying to write the logs. Great, let me make that a tempfs directory. Okay, now this is failing. Okay, and I, again, use this as an experiment to try to figure out what do I need to do, what options do I need to be able to support this feature I want. And again, because I had this foundation to experiment. And once I get it right, well, then test pass is good to go. I can theoretically run this app that was written 10 years ago in a box in a closet. I can run it in a container, and it's now in read-only mode. Okay, awesome. So the final thing I want to mention, again, since we're Docker EE customers, we have access to UCP, which is the Universal Control Plane, which allows me to see what's running where. And it gives me visibility where before it was, okay, it's a box in a closet that nobody knew about. Now I have a single dashboard that tells me here are all my containers running across my cluster. Obviously, our security office is happy about that. Okay, that's one of the things they're most happy about, that we now finally have visibility of what's running out there. So to recap, by modernizing our Dino app, okay, by containerizing our build process, putting in a build pipeline, containerizing the entire runtime now, and then building tests, that gives us a foundation to do experiments, to try new runtimes, to update single dependencies, single packages, run our app in read-only mode. We now have full visibility. It gives us this where it was absolutely impossible beforehand. And with that, oh yeah, and we did it without changing a single line of code. And so with that, I thank you and remind you to rate the session. So.
All right, we have 2 minutes left for questions, and we have a really great question that came in through the app. So you demoed you're using a Mac and using Linux. What about these techniques if you're using Windows? How does that work?
Okay, so Windows or containers on Windows, yes, you can do. Now, of course, there's caveats and all this kind of stuff too. And I'll admit, I'm not a Windows container expert, so I may not know all the the deep details and all that stuff. But all the demos that I showed off here, you can run on a Windows machine. So I would almost say it's kind of unfair because you can run Linux containers on Windows, but you can't run Windows containers on Linux. So yeah, all these things would still work. I can run the demos and spin up these containers and all that stuff you can do. Now, if you're a full Microsoft shop, of course, you'll need to figure out, okay, what application stacks are you running? Can you even do it? You can't do Windows-based GUIs, for example, but you can do .NET apps and web-based applications, that kind of stuff too. So it is possible. It just may be more work, but it's still possible.
1 minute left. Any other questions?
What version of Selenium? That's a good question. Let's see if it's in the output here. I was just using it's probably whatever the latest version is off of Docker Hub, but yeah, we can chat about that too. But yeah, so again, with the test code being its own outside application, basically, its own app source, you can use the latest, greatest, or whatever too. Or if you already have a Selenium or a Selenium hub within your organization, you can connect to that or do whatever from there too. Anything else? Okay. So I flew through the last slide. If anybody wants to reach out to me, I'm on Twitter, MikeSir87, so feel free to follow me, tweet me. I've got my direct messages open. If you have questions, feel free to let me know. There's my email address too. So with that, I guess, thank you.